All right, you guys, let's go ahead and get started. I see a couple of you guys are on here. So again, the way that this normally works is that off to the side in the chat box, you guys can ask me questions and I will answer them as they come in. So you can do several different things. The easiest way to do this is for you guys to reference a problem from homework. So if you tell me what homework assignment it is, I can walk through it, or you could always reference from our quiz that we had. So I do have all those assignments in front of me, and you can reference any one of those. So I'll wait a few minutes, get a few more people on here. And again, once you guys start having questions, you guys can type it into the chat box and I will answer them as they come in. Let me also know that you guys can all hear me, that the sound is coming through well. "4B, yes, I can." Okay. And you know what? I think maybe the unit view is the one thing I don't have in front of me. Well, let me see if I can find it in my... Nope, I have it. Okay. 4B. "4B or 5B? Do you want the one that is about the experimental yield, or do you want how many atoms of aluminum are formed? I just want to make sure that we're on the right page. Okay, cool. All right, so we're going to be looking at 4B. This is on our study guide. Okay, so up at the top of 4B, you are given a balanced chemical reaction. So our balanced chemical reaction for this problem, which is important, is 3 solid magnesium atoms plus 1 mole of aluminum sulfate. And we are told that that produces 2 atoms of aluminum. And I'm going to write this down here, 3 moles or molecules of magnesium sulfate. One thing that we can say about this reaction is that this is a single replacement. So if you look at this reaction, what you see is you have magnesium forming a bond with the sulfate, and then aluminum gets by itself. So we have one thing replacing another, and that's a single replacement reaction. So what we are going to do is we want to know how many atoms of aluminum are formed when 19 grams of magnesium are used. So if we look at that problem, I'm going to create kind of a map. So if you have your map, your mind map in front of you, you can kind of follow along. So if we start off with grams of magnesium, we're going to first convert that into moles of magnesium. Once we convert that to moles of magnesium, we can then find moles of aluminum. And once we find moles of aluminum, we can find atoms of aluminum. And to do each one of these steps, this would be our molar mass. This would be our ratio of moles to moles. And this right here would be Avogadro's number. So we have our molar mass of magnesium, a ratio of magnesium to aluminum, and then we're going to plug in Avogadro's number. So let's go ahead and start plugging some of this information in. So start with what's given. We know we have 19.0 grams of magnesium. And so I'm going to plug in my molar mass of magnesium. So we look at our periodic table and we see that our molar mass is 24.31 grams of magnesium. Put grams on the bottom so it will cancel out. Over 1 mole. Units cancel out here. So that's my first step right here. Next, I want to look at my mole to mole ratio. And again, my mole to mole ratio comes from these numbers up here. So what this says is that we have 3 moles of magnesium to 2 moles of aluminum. Since my magnesium's right here, I'm going to put my magnesium on the bottom. So this is going to be my 3 moles of magnesium. Goes down here. And then we're going to compare that to my, whoops, let me erase that. To my 2 moles of aluminum. So that's my mole to mole ratio. And then to get to atoms, we're going to be using Avogadro's number. Now those moles cancel out. So this is going to be 1 mole of aluminum. And then Avogadro's number is 6.02 times 10 to the 23rd atoms. So let me grab a calculator really fast and plug this into our calculator. My calculator does not want to turn on. Give me a minute. Great. Okay, so we have 19 times 2 times 6.02 to the 23rd. Then we're going to divide that by 24.31 and then divide it by 3. So you guys can double check my answer, but I got this to be 3.14 times 10 to the 23rd atoms of aluminum. So there's your work. And let me just put one more arrow right there. So here is, again, 4B from the study guide, and that is converting grams of magnesium to atoms of aluminum. How to use calculations. Serena, for the calculations on limiting reactants, you actually don't need to do that. The only thing you need to know about limiting reactants is what is a limiting reactant, and that's really it. So I asked you, so you can cross that out of your standards or your objectives. So you can cross that out. You don't need to know how to do the calculations to identify limiting reactants. All right. Other questions that I can answer and go over? Other questions? Experimental yield. Okay, so let's just kind of talk just briefly about the difference between experimental yield and theoretical yield. So theoretical yield versus experimental yield. Whoops. All right, so let's go ahead and kind of differentiate between these two. So our theoretical yield, that tells us how much we should have gotten. Or we'll say produced. And we find this using stoichiometry. So for example, in the previous example that we went to, let me go to the previous page. This is our theoretical yield. Theoretically, if we had 19 grams of magnesium, we should be able to produce 3.14 times 10 to the 23rd atoms of aluminum. Now, in real life, we usually don't get our theoretical yield just due to things that happen in a lab error, technique, human error, just things happen and we usually don't get this amount. So this is ideally how much we could have had. And we find that using stoichiometry. In experimental yield, this is how much was actually produced. And how much was actually produced, this comes from your data / your lab experiment. Whoops. And your experimental yield is usually a little bit lower than your theoretical because usually you're not going to produce all of what you should have. There are really weird circumstances where for some reason you might produce more, and that could be due to something contaminating, some other error. But the main difference is that this is how much you should have produced. This is how much you actually did produce. So if we think of the one that we have in our lab. So let's look at number 5. So let's use this to look at our lab data from number 5. So this will be number 5 on our study guide. So this is the lab data that we had. We were also given this reaction. And if you were to balance it, this is what you would have gotten. And you're given some lab data. You're told that the mass of the crucible is 24.50 grams. The mass of the crucible and the magnesium is 24.95 grams. You want to figure out the mass of the magnesium. And you simply do that by subtracting those two values. So your mass of magnesium should be 0.45 grams. And then you're given the mass of the crucible and magnesium. So the first thing that you're asked to do is to find your theoretical yield. So to start with that, let's start with our theoretical yield. Our theoretical yield is going to be using stoichiometry. And you're going to start with how much magnesium you burned. So you kind of want to ask the question, for example, for this one, if you used 0.45 grams of magnesium, how much magnesium oxide should have been produced? So this is just kind of the question that we can be using to ask ourselves about the theoretical yield. So using our values, we're going to go from grams of magnesium to grams of magnesium oxide. So 0.45 grams of magnesium. We're first going to convert this into moles. So 31 grams of magnesium. And then 1 mole of magnesium on top. Units cancel out. Then we're going to have our mole to mole ratio, which is actually a 2 moles of magnesium to a 2 moles of magnesium oxide. And then we're going to use our molar mass of magnesium oxide. So 1 mole of magnesium oxide. And then our molar mass of magnesium oxide is 40.31 grams of magnesium oxide. And if we calculate this, this is how much we should have gotten. So let me calculate this really fast. 0.45 times 2 times 40.31 divided by 24.31 divided by 2. my calculator just turned off. We should have produced 0.75 grams of magnesium oxide. Let me just double check that, make sure that works. 0.45 times 2 times 40.31 divided by 24.31 divided by 2. Okay, yep. So that's the answer we get. Now we want to figure out what is our, based off of this and our data, we want to figure out what is our experimental yield. I'm going to have to go to a new page. So now we want to know what is our experimental yield. And if you look at your data, we want to know what is our experimental yield of magnesium oxide. So what we need to do is we need to subtract a couple things. So we know our mass of crucible and magnesium oxide. And we're going to subtract the mass of the plain crucible. Once we subtract these two, that'll get me the mass of magnesium that we got from our experiment. Excuse me, magnesium oxide. So we have 24.50 grams minus 25.12 grams. And let me just 24.50 minus 25.12. And whoops, I should have flipped these values. Sorry, you guys. And I got 0.62 grams of magnesium oxide. So this is how much I actually did produce from my experimental. So notice if we compare this to what we should have produced, we should have produced 0.75. We only produce 0.62, so a little bit lower than our theoretical. And again, we can figure out what is our percent yield by taking our experimental, which is 0.62 grams of magnesium oxide, divided by how much we should have produced, 0.75 grams of magnesium oxide. So this is our percent yield. Times 100. So if we have 0.62 divided by 0.75, multiply that by 100, we get 82.67%. The closer to 100% that we have, the better, because that means that we get closer to our experimental yield. This isn't a bad yield. We just don't have exactly as much as we could have produced. So there is some error that could have occurred there. So there is that problem. When we look at this and we ask ourselves that should be not, so I'm sorry, I just see an error on my, on the wording of part 5D. So if we look at 5D, it should say what reactant, not what product. So what you want to look at is you want to be looking at your magnesium versus oxygen. Which one is your limiting reactant? And our limiting reactant is our magnesium, because that's what's going to be consumed first. We have oxygen all around us, so that's going to be what's called our excess reactant. So magnesium is our limiting reactant. So I'm going to put not Mg, but limiting reactant, so Lr. That's going to stop my reaction because we're going to consume all the magnesium, but there's still going to be oxygen left over in the air for us to react. Okay. Other questions? Other questions that you guys have? Go ahead and type the questions into the chat box if you guys have more. All right, so writing reactions into words. Okay, I'm gonna pull, so let's look at that. So we wanna look at writing reactions into words. So let's look at an example. I'm going to pull an example from our balancing, and I'm going to pull from our study guide. So the first thing I want to do is go over balancing this problem that we're going to look at. This is aqueous plus H3 PO4 aqueous Ca3 PO4 2, that's solid, plus H2O. That's liquid. I'm going to put my L right there. Okay, so first let's balance this reaction. So when we're balancing this reaction, notice that we have OH and we have H. These two things together are going to produce water. So if we write this like that, that's the same thing as writing water. So when I actually balance this problem, it actually makes a lot of sense to look at water as this instead of looking at it as hydrogen and oxygen. So I'm going to balance my reaction this way. So what I'm going to do is I'm going to be balancing my calcium, hydroxide, hydrogen, and then phosphate. And remember, when they stay together, you want to try to keep them together. So on this side, I have 1 calcium, 2 hydroxide, 3 hydrogen, 1 phosphate. And on this side, 3 calcium, 1 hydroxide, 1 water, and 2 phosphate. So let's go ahead and start balancing this right here. So I have 3 calciums as a product, 1 as a reactant. So I need to put a 3 in front of here. That changes my number of calcium to 3, but that also changes my number of hydroxide now to 6. So now I have 6 hydroxides. So if I want to get 6 hydroxides on this side, I'm going to put a 6 in front of my water over here. That changes the number of hydroxides, but that also changes my number of hydrogen. So now I want 6 hydrogen over here. I already have 3, so in order to get 6, I'm going to put a 2 in front of there. That gives me 2 hydrogens and 2 phosphates. And now that reaction is balanced. So those coefficients are really important. So when we write this out, the first thing that we want to remember is that when we write out a chemical reaction in words, we need to have the amount, which is our coefficients. We need to have, we'll say the measurement, which is going to be moles, atoms, or molecules. We need to have the state, and what I mean is the state of matter. So is it aqueous? Is it solid? And then we also need to have the name. So there's a couple different things that we want to make sure we have when we're writing out these reactions into words. So let's start with my first one. So right here, the first thing I want to do is I want to name this. So I'm going to say that I have 3. And this is a molecule because it's bonded to something else. So I'm going to say 3 molecules. This is aqueous. So it's of aqueous, AQUEOUS. And this is calcium hydroxide. So 3 molecules of aqueous calcium hydroxide. So I just named that. And what is it going to do? It's going to react with two molecules because again, it's bonded to other things, of aqueous, and I don't expect you to know this, so if I were to ask you to name this, I would give you the name. You should know how to name this. This is actually phosphoric acid, so I would give you that because you guys don't know how to name that. So phosphoric acid. And what does it do? It produces or it yields. So we'll say, whoops, to produce. Okay, let's start naming what we have. We have one molecule of solid calcium phosphate. And it is also going to produce 6 molecules. Whoops, this should be written out, not like that. So let's go 6 molecules of liquid water. Okay, so again, I have the amount. The amount is the 3. The measurement is the molecules. Molecules, if you didn't want to write molecules, we could also call this measurement a mole because they can be interpreted the same way. So if you wanted to use a mole, you could have used a mole. The state is the fact that we have aqueous, solid, and liquid. So those states. And then the name. So we have calcium hydroxide, phosphoric acid, calcium phosphate, and then water. So that's how you would write it out in words, making sure that you keep all those different parts when you write it out. Other questions? Other questions? Anything else you guys want me to go over? Let me know. All right. If you guys don't have any more questions, we'll go ahead and call it good. I'll wait another minute or so if you guys think of anything. But if we don't have any more questions, we will call this review good. All right. So we're gonna go ahead and call it good since it seems like we don't have any more questions. So hopefully this was useful. Don't forget that you guys have your um, study guide tomorrow. Do your homework packet, your objectives, and we'll review. If you guys have any questions, I will answer last minute questions, but then we will take our tests. So good luck reviewing, and I will see you guys tomorrow.